All right, let's get started now. Happy New Year to everybody. It's 3101. Just make sure you're in the right class. I will talk about today, mainly for the first class, nothing very technical. We might get to some motivating problem for this course, maybe at the end. But I really want to clarify about how the course is going to be run, everything, right? So I'll give you all the things you will know, and of course, interrupt me for questions if necessary. I will try to record all the lectures every time, and then I'll try to post it. You can definitely review when necessary, right? But I think today is mainly about just get everything clarified, just know exactly what the expectation should be for this course, okay? So let me go over some slides, and then I'll get to the study slide, and then many things, okay? Everything's there, just to start with. And then we'll cover something more technical on Wednesday, okay? All right, so for those of you who don't know me, Jackie, so call me Jackie. I definitely don't mind, but if you want to call me Professor Jackie, no problem, okay? I'm very informal. And so throughout the course, if you need any advice on how to teach better, feel free to suggest to me. I will definitely consider. Okay. And then, so there will be a midterm course evaluation, not formal, but it's going to be over E-class. I will release that around the reading week, and hopefully you guys can participate, and then I'll give you guys some bonus if we reach some threshold. I'll definitely let you know. Okay. And then, yeah, just give me any suggestion you like about how I can help you learn a bit more, because the course is going to be, well, naturally it's a challenging course, but I think naturally, but it's an algorithm, right? You definitely have heard about this course before, but I think that's something I want to clarify with you as well. But you want to know what would be the best way to really study this course, right? All right, so just in case you haven't enrolled in this section just yet, but if you want to, please give me, just email me your name, student number, passport ID, and then I will add you to the E-class. But most of the stuff will be open access, really. So you don't really need that much stuff from the E-class. It's mainly about announcement, okay, from me. And then, yep, so just keep up with the materials as if you were enrolled. I think at some point there will be, the comment will ask for my approval. So given that if you really keep up all the materials, I'll definitely give you my permission to enroll. So just keep up with all the materials. Okay, writing email to me. I really don't prefer email, but if there's something really quick, you can always write me email. That's okay. But if I don't respond to you or being very slow, come to see me in person. I do have enough office hours for you guys for this term. Okay, you don't need to be very formal, but I'm not going to trouble your time, right? But in-person communication, the most preferred, especially if I'm more than happy to discuss with you about grading, about how to improve in this course, etc. But in person, I normally don't really discuss that over the email. Okay, please understand that. Okay, this might be slightly unpleasant for me to say this, but I want to make sure everybody is clear about the expectation for the class, right? I really take my teaching seriously. I want to give my best to you. At the same time, I think it's really good that we try to keep the learning environment as respected as possible. I'm going to present this slide very quickly, make it clear, and then hopefully we'll just move on. All right, let me just make it clear. Lectures are recorded, and also I will take attendance starting from next week. So I think for Thursday, we can do some trial attendance on the iClicker. I'll give you guys some detail from the syllabus, okay? But you definitely are more than encouraged to attend the classes. I think it's going to be worth it. All right, and then, so if you do decide to come, like you guys, please, these are the rules. Please don't talk, okay? Doesn't matter how low the volume might be, please try the best you can, all right? Phones should be put away. All right, so, but I'm gonna keep us very busy throughout the lecture. I've got lots of examples to discuss with you, our algorithm, many things to go over with you, so you really don't distract yourself by the phones, okay? So please put the phones away. And also put your headphones away as well, all right? That one should be understandable. And now for laptop, I definitely will appreciate if you actually use a laptop to really follow along the slides. We'll take notes, but not for anything else, not in my class, right? If you really have to complete the assignments, either for this course or other course, I'd rather you do it outside my class, okay? I want to make it very clear to you, all right, please, okay? All right, it's a general warning just for everybody, right? I don't really want to give reminder to waste everybody's time, right? So hopefully I don't really ever have to exercise this at all throughout the semester, all right? So when I really find it's really distracting to me, I may have to ask you to leave. In that case, please, no arguments. or I might just involve other sources to help. All right, so guys, I know it's a bit unpleasant to hear at first, but I want to make it very clear to everybody. Okay? It's really for the sake of myself, presenting the materials to you, and also for you to pay attention. Okay, that's it. All right? Okay, hopefully everybody understand that. I really appreciate that. Thank you. Okay, so now, this is something kind of new today because I got many your fellow students actually expressing to me concern, misunderstanding, comment, etc. I decided that maybe I'll try to write a very short letter just to maybe address them. So this letter here is it's public, nothing private. It's already on the course website. But for today, I'm not going to really go line by line. I want you guys to really read it. Just take a few minutes to really read the letter. But I want to just highlight certain points when we go through the syllabus. Consider that as part of the expectation for this course. Okay? But that's something I will actually go over some parts with you today. Okay? Just some parts. But for the rest, please try to read it carefully. That will definitely help about what the expectations are for this course. All right, course information. So there is the E-class site, just for section Z. I think the E-class is already visible to all of you. Nothing substantial just yet. I think there's only a link to the lecture site, but I'm gonna mention the link to you as well. So later on, most often you will just hear announcement from me from E-class. So please just check your email very regularly. Okay, I would say more than once a day. Okay, that might be more recommended. Assignment instructions, there will be assignments consisting of programming and also written. So there will be like a mix, like a hybrid assignment. I'll talk about it a little bit later. The assignment will be the best way for you to really participate, to learn, and also get yourself prepared for the later evaluation. Okay, so that's something you want to pay attention to. But I'll talk about it. There will be a written test, just one. That's more like a midterm. There will be 3 tests in total. But for this written test, it's going to be over E-class. They could be multiple choice. They could be written answer, etc. So I would say for the test, you can ask me some general information if you need to know. But I would say I'll leave the more specific detail when we get a little bit closer to the test. I'll definitely send you some PDF guide to tell you what you can expect and the coverage. All right, and also midterm course evaluation. What about programming test? So programming test, it will be done also during the I'll talk about it more detail in a tutorial session, but it's going to be in a different lab, right? I'll talk about it. Okay, that's about E-class. All right, so far, hopefully everybody's okay. Okay. Okay, for the lectures and also tutorials as well. So your tutorial will be the same time, but on Thursdays. I will run the tutorial myself. By default, it's going to be in person, unless if there's an ice storm, snowstorm, whatever reason, extreme weather, if the university is simply shut. In that case, we may have to move over Zoom. Otherwise, I'll be happy to see you guys in person. Okay, I'll try to encourage you to come, maybe by taking attendance. All right. So lectures and also tutorial, I'll be running them myself. So you can definitely feel free to come and then talk to me. Slides will be self-contained, as you will see, as we start more technical stuff on Wednesday. So I'll try not to read them, read off the bullet points. I'll try to work more on my iPad to go over with you examples. All right, so examples, a concept, right? You can definitely study slide as well. The good news, there's no textbook, no required textbook for this course. But I'm going to recommend for those of you who may want to read, maybe either online version or maybe you want to buy a shelf copy for yourself. I do have some recommendation on the syllabus. I'll refer them to you. They're all good, right? So algorithm is a very common subject. You can definitely find lots of good textbook out there, right? The textbook I actually recommend on the syllabus, I think I do have some of it, a copy in my office. You can feel free to drop by. If you want to flip some page before you decide if you want to buy, you're also welcome to. Okay. Okay. And just ask questions. I definitely don't mind being interrupted anytime during the lecture. Okay. Okay, required study materials. This will be the site you want to pay more attention to. Okay, I would say even more than E-class. So this one here is going to be all the lecture recordings, all the slides, etc. Okay? So let me just go there very quickly. Okay? If you click on the link, it's going to be there. Otherwise, what you can do is you can easily Google for that. You can Google for EECS, York-U, and then Jackie. All right? You can easily find my site. Should be the first hit. And then you can go under lectures. Okay, you can see under winter, this term, and also 3101 right here. All right, Let's just go over very quickly about the stuff. There's already some stuff over there, but mostly the background and also the more administrative related stuff about the course. So my office hour is going to be in person by default. It's going to be upstairs, okay, 2043. There's no way you can miss it. You just go to upstairs, second floor, ask anybody if you're wondering where I might be. Okay, it's second floor. I will also leave a Zoom link over here just in case. So I really don't prefer to really go online for meeting, but if you really need it, you can still email me. We can make an appointment. That's not a problem. Okay, but just by default, it should be in person. But the Zoom link is over here just in case. Of course, let's say if in case there is an extreme weather condition, we have to move the lecture online, we might do it over Zoom as well. Okay, but I'll keep you guys posted. All right, this section here, okay, is really there for a reason. Okay, for this course, 3101, you can think about it's more like a continuation of 2101. So we are definitely going to cover data structures, algorithm for sure, especially we're going to cover a very general data structure called graph. And I think it would be very practical and useful for you guys to know how to program graphs in Java. Of course, I'll give you enough practice in the assignments. I can talk about different highlights for the solution in the tutorial to make sure you're prepared. But you got to make sure you have to review the basic Java you learned back in the first year, second year, and also 2101. Right? So I'll leave the links over here. If you're not exactly sure which parts you may want to review, you can come and speak to me. I can give you some idea. You definitely don't have to review the whole thing. You don't have to. It's not worth your time, right? But there might be certain parts you have to review about Java, right? So this will be very important background for your programming test. Okay, there will be 2 programming tests, which I'll talk about. All right, so this one here, GitHub, maybe many of you are already using it because they will be programming assignments. I would suggest maybe you can check in your programming assignments, maybe as in your GitHub, maybe after the semester, it can make it public just to showcase what you have done. Okay, that will be an option for you, not required. So this one here is something I will talk about, I will mention in the motivating problem. Since you guys already completed 2101 and you learned about how to program trees, right? So now you are in a very good standing ground to learn about how to program in compiler. So compiler, unfortunately, is not really a required component in the curriculum. Not in software engineering, not in computer science. It's more like an elective course. I taught a course a few times, but there is a tutorial there which will walk you through about how to use a compiler tool called Antler. That one there is completely using Java. Okay? So I would say for those of you who may want to do some side projects applying what you have learned in 2101 and also in this course, compiler would be a fantastic idea. I'll give you a little bit more like a visual idea. So for those of you who may want to dive into this area here, optional, but you can also feel free to speak to me throughout the semester. Okay, more than happy to look into that with you. But again, compiler, optional here, but very, very important skill for you guys to know. All right, we got links for the course syllabus and also the letter I spoke about. I'll just talk about just certain highlight for the letter. I'm not going to read the whole thing. You guys should really read it by yourself. Okay. And then the slides I'm presenting now is there. And then the weekly schedule, just about the session that we'll be hosting, and also the semester calendar. That's something I will also talk about as well. That one basically highlights about when the test will be, and also when the tutorials will be, etc. Okay, I'll talk about it as well. All right, so just about the table here, you can expect about within 1 or 2 days after each class. I would say, let's say for Monday, you can expect this one to be updated before Wednesday. For Wednesday, maybe before possibly Friday, etc. I'm going to post all the lecture recording, but technology might fail. So far, it hasn't failed on me many times over maybe the past 7 years, but if it does fail, I'll try to see if I can find any past recording. If I cannot, anyway, so just make sure you come to class. You should be okay. So there will be a link. It's on YouTube, completely open access. And also there are 2 files over here. I'm going to use my iPad a lot to really go over with you the concept. So there are 2 files over here. The right-hand side is the template files. So for those of you who might prefer to actually take your notes on the iPad, or maybe want to load to your computer, whatever you like, okay, I'm going to provide that to you. I'll try to make it available maybe by, let's say, 10 a.m. on the same day of the class. You can definitely check right before the class to load it to your computer, etc. Or you can print it out. If you want to write something on the paper, you can do that too. Okay? The choice is to you. And then the left-hand side is going to be the annotated version, which I'm going to also post. So I'm pretty sure your handwriting will be better than mine, but I'm going to give you my annotated version as well, so you also can take a look. Okay. So that's about all you need to know about the study side. Any questions so far? Okay. So I would say this side here. So there will be a substantial exam at the end of the semester. So the exam is going to cover everything I'm going to make available here. Okay. Also for tutorial recordings, exercises, solution, etc. Everything will be here. All right. Okay. Just want to make sure I don't miss anybody. Okay. If that's really cold, please wear the jacket, wear the coat. All right. So that's about the site. And the course syllabus, I'll go over that with you section by section in just one moment. All right, so, again, it's really your call to really skip the lectures if, given that everything is recorded, right? But, I would really prefer you to come, it will be your call. Come and ask questions, try to understand as much as you can, and then you can fill the gap by referring to the recording, right? I think that might be the best strategy for you, my recommendation. Okay. Okay, any questions before I go on to the syllabus? All right, let's now move on to syllabus. Right, there we go. All right, you can click on the link on the lecture site, and then you will see the link. And just for your information, so whatever we say today, in principle, there won't be any changes. Oh, sorry, go ahead.
So for tutorials, will you post it under your lectures as well?
Yeah, it will be the same. You can.
Same like table, right?
The same table, yes. May not be the exact same cell, but different table. Yes, exactly. Yeah. Okay. All right. Okay. Also, for your information, in principle, everything I say today about the policy wouldn't change. However, university also allow me to change the policy until January 19th. But if I change anything that's going to be different from what I say today, I'll let you know explicitly. So don't worry. Okay? Whatever I say today, you can assume it's going to be the case. Okay? Until 2 weeks from now. Okay. Many sections over here, but I will just go over with you the critical parts, and then I will briefly mention some section heading just in case you got to use it. Okay. All right. Number one, assignments. So there will be 3 assignments. I'll go over the grading scheme with you, but for all the assignments, it's more like a participation-based. Meaning that as long as you can submit your best attempt before the submission deadline, you get full marks. It will not be graded. However, I'll give you the complete solution. And also in the subsequent maybe tutorial session, I can also walk with you certain part of the solution, right? The assignments are really there for you to learn and make sure you're well prepared for the subsequent either written test or programming test. There will be written part and programming part for the assignment, right? Just make sure. And also, in my open letter, I also mentioned that, can you use ChatGPT? Yes, you can use it. You can use DeepSeek, Cloud, whatever you like, right? Use AI to help you learn. No problem with it. Can you work with your peers? Yes. Can you ask Jackie directly for solution? Yes, I can try to lead you to the solution. No problem. You can do all these before the submission deadline, as long as you are learning. All right. Make sure you just get prepared for the test. All right. All right, so please read this section here. It's a bit long, but it's really say completely exactly the philosophy of this design. Right? Again, even if you submit empty file before for the assignment, I will still give you full marks. Right? Just be honest to yourself. I'm pretty sure you will be. I'm just saying. Right? Just make sure you submit the best attempt. It doesn't need to be perfect. You will not lose any marks by submitting imperfect work. Not really. Okay? Is it clear to everybody? I just hope, right? Okay, no stress about the assignment. Only stress for the tests, naturally, right? That's better. All right, test and location. So basically, our tutorial session will be on Thursday, 2:30, but that one is in the Stedman Lecture Hall, not in Lausanne. But for our written test and programming test, it's going to take the same time, 2:30 on Thursday, but it's going to be a different location. Most likely Williams Small Center, but I need to confirm with you. I'm still trying to figure out the reservation, etc. But I should be able to confirm by the end of this week. Right? But you can now assume it's going to be Williams Small Center only for the scheduled test day. For normal tutorial, always in the standard lecture hall. All right? I'll definitely see you guys there this Thursday. All right? Okay. Dates and location, yeah. And of course, schedule will be individual, nothing to say. Okay, for assignment, there's nothing about plagiarism. You don't need to worry. You can do whatever you like to really work on the assignment. Just make sure you learn. That's the only thing I care. Okay. All right, guys, just in case you missed the test, hopefully everybody will be here, right? Please don't miss the test. It's not going to be healthy, right? Of course, in case you have to miss it, I understand that, right? I would say if you have to miss a test, just read the section here and then figure out. You got to reach out to me, right? And if you got the university accommodation, please also reach out to me as soon as you can by the end of this Friday, and then we'll talk, right? Just figure out what will be the best way for you to take the test, okay? And enrollment, right? Just make sure you send me your information. Any questions so far? All good? Okay. Okay. All right, that's me, and then that's my email. All right? Just Jackie@eecs.yorku.ca, okay, email. But I really, really prefer in person, okay? My office hour is going to be 4:30 to 5:30, Monday, Wednesday, Thursday. So if you already want to speak to me, I'll be happy to. I'll be here. I'll be in my office, okay? It's about half an hour after the session, so it's easy for you to remember. I'll be there today. You can speak to me. More than happy to. That's my office, 2043. And then that's a Zoom, all right? Okay, so lecture and tutorial. In person, okay, prerequisite, I'm pretty sure everybody has it, all right? That's good. Okay, E-class, I talk about it. Also for the lecture site, I'll make it a little bit smaller. Okay, sorry. Okay, the site I just went over with you. That's the site. And now, that's the background about Java. Oh, by the way, so you might be wondering, what should you know about Java? I would expect you to know, for example, you should know how to work on Eclipse. You should know how to create a class. You should know how to create a method. You should know how to read JUnit test cases. And also, you should know how to use a debugger. And also, you should know how to use library classes like array list, hash table, etc. But don't worry, I'm going to prepare you for that. We'll do exercises in the tutorial and also in the assignments, right? But you just got to make sure you spend the time and also struggle and let me know. I'll go help you with that. Okay? So that's about the background. These are the optional textbook. I don't really have them today. I'll try to see if I can bring a few, maybe a couple, maybe on Wednesday. You can see they're all very thick. So I would say if you really want to buy the copy, it's really recommended you get a shelf copy for yourself. It's going to be very beneficial. Either you go to academia or industry. Algorithm is a very fundamental subject to always keep yourself be reminded. Okay? But my examples will be maybe sometimes drawn from this textbook. Maybe I'll look at other sources, but the required material will be my slides and all the notes, all the examples I talk about. Okay? If you don't really want to read any textbook, that's also fine. But I will recommend at least get a book to fill out some gap. Oh, by the way, so this book here, okay, right here, that one here is actually published by faculty member in Princeton. I think they have a very nice website with lots of with the slides and also with the recordings over there. So you can also refer to them. I think it's a very nice way for you to actually complement, the lecture. Okay. All right. So far, no question. Okay. Good. So let me see. Okay. So why don't we go over very quickly just about the course description, some topics, and also the course learning outcome very quickly, and then we'll talk about grading scheme. Or maybe I can talk about grading scheme first. It doesn't hurt. How about here? Okay, and then we'll talk about other things. Okay, so that will be the grading scheme over here. Just to start with, there will be 3 assignments in total. Okay, 5% in total. As long as you submit all your best attempt before the deadline, you get 5%. No question asked. All right? It's really for you to learn, participation-based. So there will be 3 tests. There will be 2 programming tests over here. So these 2, I'll definitely give you more detail. Also, you will get a very clear sense once you get the assignments, the programming part. I'll also give you guys a guide also before the test. Good news, your very first test is not before the reading week. It's actually right after the reading week. So you do have time to get yourself mentally ready and also physically ready as well, right? You really want to make sure you learn the stuff, right? So it's after the reading week. So these 2 tests, I haven't finalized exactly the topics to be covered just yet, but I can tell you that for sure, programming test 2 is going to be about how you can code some algorithm as methods in Java for graphs. Of course, that's something we're going to talk about in class as well. Okay? I was debating myself whether I should really make maybe the first programming test slightly lighter and maybe the second one slightly heavier. But I kind of decided that I'll just make them equal weights. You can expect that programming test 1 is going to be maybe slightly easier than programming test 2. At the same time, it's going to be the first time you take a programming test for this course. So, many factors, put into consideration. I'll just make them equal weights, okay, 15% each, okay? It's going to be JUnits based, meaning that you will have to make sure you know how to do everything from scratch and also read the JUnit test cases and also pass them. All right? And in the open letter I just mentioned, I'm going to go into details about the programming test, but there will be a section there just talk about what's really the rationale for designing this. Okay, I'll show you some sentences later. Okay. And we got written test right here. So written test is also 15%. I think this written test here will be to your advantage, because this written test here is going to be around week number, I forgot exactly, but we can check, about week number 9 or 10. So that one there is going to be also a nice way to make sure you study also at the same time for the exam ultimately as well, because you cover all the materials up to and including that point, which is already after reading week. Anyway, we'll see. And the exam. Okay. Cumulative, meaning that everything we cover in the course except today is going to be covered in the exam. All right? So, got to make sure I do have some ideas about what might be the best way for you to get prepared for the exam. It's in the open letter, so please read it, right? It's a really nice letter. I think I will definitely go over with you some sentences, but exam, on day 1, there will be a huge exam. Old school, paper and pen, maybe the exam center or maybe somewhere on campus. And you got to make sure you know how to express yourself, how to do reasoning, how to do proofs, how to write some code, etc. Right? Everything will be on the exam. Okay. So if you really somehow couldn't really do well on the test, exam will save you, hopefully. On the other hand, if you do too well in those tests, watch out for the exam as well. Right? So, I think just think about, at the end of the day, all I do is math. I can only do the weighted sum according to this table. So but you know right away. Okay? So think about what I will say today about how the course is going to be run. As I said, before the reading week, there's no test. Think about what may be the best pace for you to really study. And the strategy I will highly recommend is to read that open letter. You will have some inspiration from there. All right? Guys, any question? Okay? Okay, so after this, this is the open letter. I'll just go to open letter right away, and then we'll move on to some topics for today. Okay? I'll try to make it very brief. I know that maybe you really prefer to really read a letter. It's more like a private thing, personal thing. I will definitely let you have it, but I'll just highlight some sentences. Okay? Letter. Again, the way for you to find the letter is to simply go to the site right here. And then here, letter for me. All right? Okay, let's now just read some sentences together. Just some. Okay. So the letter, I'm not really trying to, stimulate some very heated debate. Not really. That's not my point, right? I'm just trying to say what I honestly think. You can disagree, that's okay, but at least this letter here tells about the philosophy behind how this course is going to be run by me. All right? So, I'll just go over some sentences. Now, I don't want to take too much time. Okay? let me see. There we go. All right, so these really just address maybe some misunderstanding, but I would say most of the student, or everybody here, I'm pretty sure you got very good efforts and also intense, but there might be some misunderstanding about how exactly to do well in the course. That's why I wrote this letter here, right? So that's the first thing to clarify, what's the intent for this letter. Again, I'm not really asking for heated debate from you. That's not my point, okay? Okay, this is why I like to play with that a little bit, right? Logic. You guys took 1090, right? And I do recognize some faces from 3342. Also, wow, even more logic, okay? But, okay, even though it may sound like a little bit of teasing you guys, but it's really, really what I meant. Okay, I'll just mention that. That's something I want to spend a little bit more time. Okay, teaching is necessary. I try to do as good a job as I can, but what I normally have from the student is they may post on Reddit, post online to say, oh, in his class, more than half of the students fail. He's not a good teacher. In some way, I would say that's not exactly wrong, but I would say that's just not very accurate, right? I do want to respond to it, in front of you guys over here. So your fellow student is trying to say, good teaching implies good performance. Do you guys know contrapositive? P implies Q. Means not Q implies not P, right? If the performance is good, not good, half of the class fail, that means he's not good in teaching. That's the reasoning. Not exactly accurate, not exactly, okay? This is what I think will be the more accurate characterization. Good teaching is definitely necessary, but not sufficient. That's why I want you guys to really tell me how I can do better. I'm really open to that criticism. If you really tell me that you teach very badly, I'm happy to change to some extent. For example, if you really think my handwriting is really bad on the iPad, I'll try to change as well. I'll try, okay? So good teaching is definitely necessary. However, there will be some X, all right? So X over here will be something that'll be up to you guys, right? So I wouldn't go too much into detail, so there will be something you have to read the letter and see what the X really meant, okay? So I think when the performance really didn't go as well, definitely it could be something to do with my teaching. That's why you want to constantly remind me what I can do more. However, on the other hand, that could be maybe something from your side as well, right? Let's be fair. All right? So that's something I want to say. I'll try to teach as good quality as I can throughout the semester, but please also do your part. And doing your part doesn't really mean you simply come to the lecture. Sure, I appreciate that. And also you complete the assignments, and also you spend some time. That may not be exactly sufficient. What will be sufficient? Please read the letter. All right? Okay. Okay, that's what I call the growth mindset. Not really my term. People talk about it, right? Okay, very good. Okay, assignment, low stress, and you got to take the responsibility right here. And then, okay, assessment format. So that's something you can also read about it, right? So I just talked about this course here is test heavy, right? You can see there's no group assignment, there's no. But I also justify that as well in the letter. You can also take a look just to understand what I'm thinking, okay? And also, so by the drop deadline, okay, you will know roughly about 15% of your grade. Given that exam is 50%, of course, you cannot know more than 50%, so about 15. After that, you still got something about 2 more tests and etc., right? So just to let you know right away. But I think this one should be sufficient enough. Of course, I hope everybody will stay. I never want to lose the students. So I would say for 15% here, that will give you a very good idea about how the lecture is being conducted, the pace, and also what might be the best study method for you. And after the very first programming test, before the drop deadline, I'll definitely return a feedback and result to you before the drop deadline. You can also get a very good idea about the other 2 tests. The same standard, the same expectation. No more, no less. All right, consistent. Okay. Okay, good. Okay, and then, okay. About the exam. Okay. Okay, make sure you can connect the dots. And also you can basically I may ask you something that might be across the lectures, right? Which we cannot do very easily in the midterm, okay? And you definitely actually want to not to really make your life, maybe 2 days before the exam, too painful, right? You definitely want to maybe make some like a steady review of the material, maybe every week. So that's why I call it host office hour. You can always talk to me, okay, about what you think about the materials, okay? Okay, so this one I know could be a little bit personal, so I'm not going to say that aloud in public. That's really about, I do appreciate when your fellow students say that, I really try a lot, but it still doesn't quite work. That would be my response over here. So please take a read, right? I don't want to confront anybody, right? I really just want to say what my honest response. And also programming test, right? So this is something I want to, just one sentence over here. So in professional settings, code that doesn't compile or they fail the correctness test, they are basically not very usable. So that's why when you submit your Java code for programming test, we got to check for compilation and also check for test cases if they pass. All right, so if your code doesn't compile, of course, this is really hard for us to really learn about how they should run. And also, if your code actually failed the test cases, it's also very difficult for us to decide to what extent it is correct. It cannot be objective, never, right? So, test cases. Okay. All right, that's why it's a bit personal, just my personal opinion. Please take a look. I will really, I'm not talking about you, I'm just talking about in general. Some of my previous students, maybe they try to really do the bare minimum just to get a grade to pass or get a good grade. They always ask me, if I do this, am I going to lose marks? If I do this, is it going to be covering the test, etc. I respect that. That's okay. Totally understandable. GPA is important. I don't deny that. But there's really some response I have from here. So please take a look. Okay. So finally, just about stress, external factor, maybe GPA, application for co-op, grad school, OSAP, full-time student status, absolutely. However, when I calculate your grades, I'm not permitted to consider them. They are not academic reason. I'm just telling you, I cannot consider them. So please, from day one, think about this letter here. Just think about how you might move on with the course. Of course, some of you may have a choice. You don't really have to stay in this section here. I'm not asking you to leave. No, not really. I want you to stay. But I know some of you, you basically have no choice, right? It's an engineering section. But since you'll be stuck with me anyway, why not just read the letter and figure out what would be the best way for you to learn? All right? That's really my honest opinion. Okay? All right. Anyway, guys, that's about it, right? The letter, please take a read, right? I basically talk about all the important points. There's some minor points you may want to read as well. I'm pretty sure that will help. If you want to follow up with some discussion, I can do that in the office hour. Okay. Okay, good. So letter's done. And then, okay, let's now talk a little bit about, actually, you know what? I think this one should go last. Let's talk about more about the calendar. Okay. So exam and also how the grades are going to be calculated. Okay. So the grading scheme is right here, right? I'm just going to do the weighted sum. You can see one example on the syllabus. To pass the course by the standard, maybe I shouldn't really say, I'm pretty sure, to really get an A+, normally you should really get 90%. Yes, but it might be lower, right? My point is, when I actually calculate you guys' weighted sum on a spreadsheet, I'll calculate at the first go. And then I'll try to see, for the performance overall throughout the semester, see everybody's engagement in general, I might adjust the cutoff. Don't worry, I'm not going to make the cutoff higher than standard. I'm not going to say, oh, to really get an A+, you need to get 99%. Not really, not really. All right? I might make it maybe 85, maybe 87. I'm not guaranteeing anything. I'm just saying maybe. And to pass the course, if that's the only thing you're asking, that's okay, that's fair. Maybe you don't need to need exactly 50%. Maybe 48, 47, There are many factors I can consider. Attendance is one thing. All right? Let me say another thing very quickly. I also recognize faces very well. So please, just make sure stay engaged in the class. I'm pretty sure everybody will. And then, hopefully, at the end of the semester, you got to give me some reason to really say you're somehow close to the cutoff. But really to bump you up or not is really kind of up to me. You got to make sure you stay connected with me somehow. I'm not saying you got to talk to me all the time, not really. But, stay engaged in the materials. Okay? Okay, good. And then workload. Okay, this is just official, right? Official workload should be about 9 to 13.5 hours. It's a 3-credit course, including all the attendance, etc. But I would say algorithm is a very important course. If you spend more than that, it's not a bad thing. Okay, I'll leave the choice to you. If you have to spend less, that might be good too, right? So it really depends on individual. Okay. All right, attendance. Okay, that's also important. Okay, again, attendance here is most of the stuff in the syllabus is just about mechanical, just about procedure. I'll just summarize and please read the detail about policy. What you guys should do is, if you haven't really used iClicker before, you want to go to this site. I'll show you. Give me one moment. Right here. Okay. Refer to the starter guide. Okay, there's a link you can click on the syllabus, right? If you're using iClicker for the very first time. Otherwise, you can simply search and add yourself to this course right here. 3101, Section Z, Winter 26, algorithm. Okay? So basically, I will take attendance, not necessarily every time, but I'll try to do every time just to really award you guys, as much as I can. So let me summarize the critical point here. Number one, there is no fixed bonus with the attendance. Okay? So please don't really come to me and say, oh, I actually got 100% attendance. Why am I still not getting A+? Nothing to do with it, right? Attendance is simply a record for me it's an indicator. So I can definitely consider to see if you are somehow close to the cutoff, I might use my discretion. Very limited, okay? Attendance is no fixed bonus. I just want to encourage you to come. That's really, right? And that's one thing, okay? It's no fixed bonus. And then number two, usually I'll just do it maybe before we take a short break in the middle. Not today. So what you guys should do, please get your iClicker installed and also enroll in the course on Wednesday and also Thursday tutorial. We're gonna do a trial attendance. Doesn't count, but just make sure everybody know the flow and also know how how things will work. And then starting from next Monday, we'll do the real thing. All right? And don't feel bad about missing 1 or 2 sessions, just in case you maybe have some emergency, if you are maybe not feeling well, that's totally fine. Missing classes is not going to impact your grade in any way. All right? It's not going to cost you any negative marks. Okay? So please read the policy about iClicker, and then we'll start doing it from officially next Monday. I'll do some trial attendance on Wednesday, also Thursday. All right? Oh, for those of you who may want to use iClicker on your laptop, which is totally fine, try not to use Firefox. That's just the experience from your fellow student. Try to use Safari or maybe Chrome or anything that's not Firefox. At least Firefox known to be problematic. Okay, now mobile phone might be the best. Okay. Okay, and then of course I can outline the policy again. I really hope that I don't have to really exercise this policy. So if you only come here, wait for me to take attendance, and then after I take it, you just leave. Right? Doesn't really bother me, but it's not fair to your fellow student here who stay for the whole session. So I do reserve the right to maybe take attendance more than one time. So as soon as you leave, I'll take again. And to really get the credits, to get the attendance credits, I put in quote, you have to fulfill all the sessions. Please, what's the point, right? Okay, anyway, so please read through the policy, okay? Okay. I'm definitely going to complain to the department about being too cold. I really feel cold. I keep talking. I'm really worrying on myself, but still I'm feeling cold. Okay. Okay. Okay, iClicker. Okay. Okay, and then, okay, let me talk, okay, protocol. Okay, this is just what I'm presenting the slides about, laptop, etc. Right? Guys, please, okay, just obey that, and then we'll be all good. Okay, calendar. Okay, and then I'll go back to the course description, etc. Okay, so that's something you may want to print a copy for yourself or store a copy handy that tells you exactly the deadline, etc. Okay. Sorry, let me just make sure. Okay, I will finish everything except for the course description, and then we can take a break. Okay, so this calendar you can also find it on the course site right here. Okay, as I said, nothing about the test before the reading week. Okay, reading week over here. So we got our lecture 1 to all the way to 12, And also we got all our tutorial session, all in person, right? I'm gonna see you hopefully in every session. I will release your assignment number 1 on this particular day, okay? In case I have to delay the release, most likely not. If yes, I'll definitely postpone the deadline as well. You definitely got enough time, okay? So you can think about assignment number 1 is going to be like a practice assignment for your programming test 1 at the same time. Right? I'll talk more about it. It might be a little bit too premature to talk about it right now, okay? You got assignment number 1, you got assignment number 2 and 3, okay? Okay, programming test 1. Okay, you can maybe put the test dates now in pencil. I have to just double check with the department just about the reservation for Williams Small Center. Okay, but it's going to be programming test 1, written test, and also programming test 2. So these are the 3 tests, 15% each. Okay, they will be in the Williams Small Center, and then at the same time as your tutorial. Rather than going to STEM and lecture hall, please go to Williams Small Center. Okay, these are the 3 sessions. Okay, and then also maybe let's say for example, let's say for this one, for this test over here, maybe in the tutorial session before that, I can host maybe some review session. We'll see. If you want to maybe to host some extra section, I can do it too. Okay, we'll see. Well, we can remain a little bit flexible over there. Your exam is going to be from April 8th to 24th. Don't make any travel plan, please. Okay, you got to stay. Okay. And the registrar office is going to confirm about the dates for the exam shortly after the reading week. I'll keep you guys posted, okay? All right, oh, very good. And drop deadline, hopefully, doesn't mean anything to everybody, right? Everybody will stay, I hope, okay? Drop deadline. But before that, please know that you will only get done about assignment number 2, assignment number 1, and also programming test 1. Close to maybe about 15+% of your course grade, okay? Any questions so far? Okay, all right. Okay, that's about the calendar. And then, just about a weekly schedule. So lecture and also tutorial. Office hour, Monday, Wednesday, Thursday, 4:30 to 5:30, 1 hour, okay? Lecture, please be there in time. I'm actually hosting the same office hour for 2101 at the same time, so hopefully it will be okay, right? You don't really need to wait. Okay, so let me just make sure everything else has been covered. Okay, and then coverage of tests. Well, that one's just only tentative, so don't take it too seriously just yet, right? I will confirm about the exact coverage when we get a little bit closer. I'll give you the guide at least 1 week before the actual test, so you're definitely okay. But try to already keep some steady review of your material. Okay, and topics over here, I'll talk about it very soon, right? So just in a very general sense, just for you to know roughly about some of the topics we're going to cover. Okay, I think everything important, more to do with the procedure, has been covered. Guys, any questions? Okay, okay, let me just see. Okay, so I think the syllabus is basically done, and then over here. Okay, I think that's the one I need to talk maybe after the lecture. Okay, if no question, why don't we take a 2 minutes break? Okay, and then please don't leave, come back, and then we'll continue. Okay, so let's now talk very briefly about the course. It's really so this part here is the official description for the course. I can go over some keywords with you. And then, so these are the tentative topics you actually find in the syllabus. I just go over them very quickly, mention some terms. And also, some of them might be already familiar to you from 2101. Okay? All right, so here we're going to talk about the design of the algorithm. Design. And specifically, we're going to do a little bit recursion, maybe as a review for 2101, but not too much recursion for this course. I think just for the iterative algorithm, like a method with basically loops, you can already see many challenging stuff, also interesting stuff to really go over. Okay? Specifically, we're going to talk about maybe a little bit later in the course, the design for something called the greedy algorithm. Sorry. So forgive my writing because my hands is also freezing a bit, right? So I'll try. is something called greedy algorithm. Okay? Greedy algorithm is basically iterative, meaning that you need loops. Nested loop, maybe, right? And then we're going to study maybe at least two very standard greedy algorithm. One is called Dijkstra's shortest path algorithm, just to see how you can calculate the shortest path. I'll give you some visual example. And also number two, how you can compute the minimum spanning tree in a graph. That's also a very standardized problem to really solve in graphs. Okay, so just see the design. And the second part, about the analysis. Okay, so now analysis, there are two parts over here you're gonna learn that we're gonna work on during the lecture and tutorial. One thing is what you learn about big O. So I think starting from Wednesday, I think I may have to do a little bit review about big O, asymptotic analysis, do some example. Especially I have some nice, interesting, challenging example to go over with you. Maybe something you haven't seen in 2101. That's a nice addition in this course. Anyway, so number one is going to be some running time analysis. Running time. And we're still going to stick with big O in this course. So there's other notation called big theta and also omega for maybe different time bounds, but stick to big O for this course. If you really have to discuss something else, I'll give you the background. So, but big O mainly. Okay, number two, the important stuff. Okay, correctness. Okay, I just want to mention two very important things over here, right here, correctness. Okay, now when we talk about correctness, we have to review mathematical induction. You have to use mathematical induction quite a bit in this course, especially when we get to the graph. Well, actually I should make it clear. What you learned back in 2101, the tree is a recursive structure. Graph is also a recursive structure, even more generalized structure. Whenever you're dealing with recursive structure, to argue about its correctness, mathematical induction will be the way to go. So I'll give you example, we'll do lots of them, and also we're going to see towards the end what kind of complexity you can actually get into. Okay, so one is about mathematical induction. Again, I'm really sorry about the word. That's the best I can do. Okay, mathematical induction. Okay, and the second thing is about looping variance. Since we're actually going to focus more on the iterative algorithm, especially the greedy algorithm, that's going to be iterative. So we're going to see how we can use something called looping variance to actually help you prove. Still use mathematical induction. We'll see. Okay, looping variance. And then we have to know how to choose algorithm. When you are given alternative, what would be the choice? Okay, let's just so this might be a nice opportunity to really recall maybe what you learned maybe back in 2101. Okay, so computational problems. A very classic computational problem is about sorting. All right, let's now open an empty page. Tell me the sorting algorithm you know about so far. Oh, sorry, Diego, just before you say. By the way, in this course, we're not going to cover any new sorting algorithm. Right? Basically, what you have already learned in 2101, that should be it. All right, so please let me know. Diego, go first. Just tell me one.
Merge sort.
I like it. Merge sort.
Selection.
I like selection. Bubble sort, I like it, but I don't really usually teach that, right? For those of you who might be interested, bubble sort may not be the way to go. There's a very popular YouTube video. Just Google or YouTube, search for Obama bubble sort. You'll see what I mean. Okay, I'm not making that up. There's really such a video. Hopefully it's not deleted just yet. All right, selection, merge, quick sort, I like it. Heap sort, I like it. Insertion sort, good. That's exactly what I need. All right, thank you. Okay, let me write it down. Okay, it's a good kind of recap. So when we talk about sorting, so first of all, let's start with the more basic one. Well, basic in the sense that asymptotically it may be more expensive, maybe the running time is a bit higher, but it's a little bit more intuitive to really implement. Insertion sort, selection sort. Insertion sort, and also selection sort. And guys, do you remember running time? Is it big of n log n? N squared. All right. Okay, insertion sort, selection sort, we wouldn't really review them in this course, so you may want to actually take a look for yourself. Okay, that could be beneficial because it's iterative algorithm. All right. Okay, first one, fifth category. And then we talk about merge sort and quick sort. Merge sort and quick sort. Now, question, running time. And log n for both, or, okay, I see that you nod your head, I like it. Can you please share your thoughts? Why? Which one is not necessarily n log n?
Quick sort because there's a probability factor, but it's most likely.
Okay, I like it. You're saying there's a probability factor. What exactly is that?
That's choosing the pivot.
Choosing pivot. Okay, what would be the best pivot to choose?
Something in the middle, like
In the middle, median. That's what you meant. Very good. Fantastic. All right. So again, a quick review. I think that when we actually cover the part maybe about solving recurrence relation, that'll be some of the example I want to review. If you haven't seen that before in 2101, that's okay. We're going to learn it. Okay. If you have seen that before, it might be nice to brush up. Okay. So merge sort, quick sort. Merge sort, always big O of n log n. For quick sort, you got to be careful about choosing the pivot. As your fellow student correctly said, if the pivot is, so there are two requirements over here. The pivot over here, number one, it should be very close to the median. Median in the sense that if you got your array that's not exact, let's say array or list, that's not exactly just sorted yet. If I choose the pivot, it's such that it's just around the middle, whereas there will be about half of the elements less than or equal to that, and also there will be also about half that's larger than or equal to that. Then that's a good pivot. If you choose a very bad pivot, it's no better than selection sort or insertion sort. Right? That's something maybe you have learned before in 2101. So two criteria. Number one, it should be close to median. And number two, this may be I will just mention the number, but there's something we may have to dive a little bit deeper when we talk about solving recurrence relation. But let me mention that. In order to choose a median, right, you can maybe picture in your mind, how do you find a median? One way to do, I'm just talking about naive way. You can sort the array and choose the middle. But that one there is going to be maybe n log n, because you got to do the sort first and then choose the middle, right? The second criterion, in order for your quick sort to actually work efficiently, the pivot selection cannot afford to be very expensive. It has to be around big O of n. All right? Don't worry, that one is not something I will assume you will know, but I want to mention that I may not be able to cover this particular algorithm, but I'll see if I can mention that maybe some reference at least, I'll let you know. Okay? Big O of n to choose the pivot. And that one there is this algorithm called median of medians. Okay, I'll just mention the name. Okay, for those of you, in case I don't really get a chance to cover this particular algorithm, you can feel free to Google, ask ChatGPT if you like, to learn it. Anyway, okay. So merge sort, quick sort. In the best case, well, in the merge sort, it should be n log n. For quick sort, depending on the pivot, it could be n log n, but you got to be careful. Okay. Okay, so quick sort, I'll just say a little bit more. It could be n log n, or it could be n squared, depending on the pivot. Okay, just watch out for that. We'll see a little bit more from the solving the recurrence perspective a little bit later. Okay, and then we talk about, okay, heap sort. That's my favorite. Because in order to understand heap sort, you have to understand what a heap is. Guys, quick check. Can you tell me what a heap is? By the way, a heap is not like a special permanent memory that you learned in 2031. It's not a heap I'm talking about. I'm talking about the heap you learned from 2101. But by the way, heap is something we have to review thoroughly also for this course, because for the shortest path algorithm, for that one to really work efficiently, we have to use a heap. But I want to just see. Anybody? Just give me the definition. Heap. Just as brief as possible, please.
Actually, it's a tree.
It's a tree, I agree. Well, what kind of tree? I like it, it's a tree. Heap invariant, okay, maybe getting some property, right?
Isn't it the one where the parent is in the middle of the child? It's two children.
I think you're more talking about like a binary search tree, not exactly. Okay, I'll take one more and then I'll move on, okay? But please go ahead.
It was a tree where the parent is either less than or more than, depending on if it's min heap or max heap.
Yeah, you're definitely getting somewhere. What you're talking about is one of the properties. Okay, I'll just write it down. What you're talking about there is called a heap order property. Again, for the heap, it can be minimum heap or maximum heap. I think for this course, we're going to focus more on minimum heap. Diego.
Balanced binary search tree.
Huh?
Balanced binary search tree.
Not exactly. Very good, very good. I like it. That could be a nice exam question. Like what the difference is between a binary search, balanced binary search tree and a heap. Maybe you can mark it down as a question. Yeah, I might forget anyway, but I would say, you can mark it down. It's a good study question. What's the difference between a balanced binary search tree and a heap? I can tell you that they're very different, all right? Okay, so I'll talk about very quickly about heap sort. Okay. Heap sort. And that one there, by the way, the running time is actually going to be n log n, okay? I wouldn't really go into details about how to do heap sort, but once you have a heap, you can basically do heap sort. That's where the name comes from, okay? But for the heap, data structure. So the heap is a data structure. First of all, it's a binary tree. And it must satisfy two properties. One is so-called a heap order property. For example, if we talk about the minimum heap, if you go to any subtree in the heap, the root is guaranteed to be the minimum. The relationship between the siblings, that's not what we care. We've got to make sure the parent's key is smaller than or equal to the child's key. Okay, it's a recursive property. So heap order property is one, and number three about balanced, right? And 2a and 2b. It's called the structural property. And more precisely, which I will define a little bit later when we get there to review, the structural property is about the tree being complete. And if the tree is actually complete, the heights will be big O of log n. That's something we'll get to a little bit later. Right? I want to mention about the facts. Okay, for those of you maybe who took maybe 2101, not just last semester, I think maybe, I wouldn't say you're in a disadvantageous standing compared with your fellow student who completed 2101 in the fall. But people forget about things quite quickly anyway, right? So I would say maybe you want to kind of review a bit about the stuff, maybe in 2101 as well. Look at the syllabus about the topics that we're going to cover, and then you may want to review as well before I get there, all right? Okay, heap sort and about the heap property here, and then, okay, good. Okay, that's about sorting. And then we have to, okay, so, okay, right, that's about tutorial. That's okay. I got about 9 minutes. Let me finish at least the topics over here, and then we'll talk about some motivating problem on Wednesday to begin with, and then we'll talk about the actual material, okay? If you look at the course description there, official one, we were supposed to review some stuff from 2101. But I think the stuff I'm going to review is all going to be useful in learning about the new stuff. All right, so just you can follow my lead about the delivery. Okay, let's go over the topics. I think that's at least something you can maybe think about, combined with the open letter I mentioned to you. Okay, so we have generics in Java. Especially, we're going to review, and you got to make sure you can do it in the assignments and also the programming tests, about linked list and potentially also trees. Okay, that's something I will try to spend maybe some tutorial session. Maybe I'll try to do that as early as possible, so you can definitely try to get some exposure to the material. You might need some extra practice yourself, but we can definitely do something already. So you got to use generics in Java and also linked list and trees. Okay, and then we're going to review about asymptotic analysis. Okay, so this part here will just be a review, which we'll do on Wednesday. Just to revisit about the definition and also how you can do some simple proof, etc. Okay, and this might be new to many of you. We're going to talk about dynamic arrays. In Java, for example, whenever you create a new array object, you have to give a fixed size. Let's say 1 million. Sorry, maybe not 1 million. Let's say 10. Okay? Let's say you have filled out all the 10 slots in the array. What should you do? You shouldn't just give an array index out of bound exception back to the caller. What you should do is you should somehow dynamically, as a programmer, grow the array size. So now there are two strategies for this. Either you can say, okay, so now I got 10 elements. They have been 10 slots in the array. They have been filled out completely. I can say I will add 5 elements each time. Maybe the first time I resize the array to be 15, and then 20, and then 25, etc. Okay, I'll write it down. This is also worth looking ahead a little bit, because this is something I want to do thoroughly as well, both the programming and also the mathematical analysis. So we talk about dynamic array. So basically, we're going to grow the array as part of the code. There are two strategies. One is called a fixed increments. The second one is called a doubling strategy. I believe the array list Java library class uses this strategy behind the scene, which makes sense because it turns out doubling is a more efficient strategy. Okay, let's talk a little bit more about it. Okay, let's say this. I have my initial array size to be 10. I got 10 elements filled out already. I can grow the size to 15. All the 15 filled out already. Grow to 20, grow to 25, etc. Okay, fixed increment. Of course, the exact increment is kind of up to you to decide, but it's a fixed increment, some constant. Doubling, also literally, you can already kind of guess what I'm going to do. Let's say you got 10 elements to begin with, filled out, double the size, 20, and then 40, and then, oh, yeah, 40, right? And then 80, right? Good, right? Something like that, doubling. Okay, it turns out the doubling strategy here is more efficient. However, not in terms of worst case running time. That's something I will explain a bit more later. Okay? It's in terms of something you maybe didn't really got exposed to. It's called amortized running time. Okay? It's called amortized or average. Running time is big O of 1. Pretty good deal. Which means if you got this strategy here, it turns out it's basically costing nothing to your code during the lifetime of your code, basically. Right? In order to really learn about dynamic array, number one, we should really study some Java code, which I will do in the lecture a bit and also in the tutorial. And the exciting part will be, how do we figure out the amortized running time for both the fixed increments and doubling? We have to somehow dive into some, I wouldn't say, rigorous math. How about that? I'm going to do some example together with you, one example maybe in the lecture, and we'll do another one possibly in the part of it, maybe in the tutorial as well. You get exposed to both. And also for these two, you have to somehow also, we got to review about arithmetic sequence sum versus geometric sequence sum. If you forgot about them, that's okay. We're going to talk about them. I don't want to mention the name. Right? So that's something we're going to get as well. Okay, so here, balanced binary search tree. Okay. So this is something right after we talk about the asymptotic analysis, we're going to talk about trees. Okay, a little bit definitely review from 2101. We're going to make sure everybody is okay. And then we're going to do some new stuff as well. Okay. So we talk about what does it really mean for a tree to be balanced. And of course, the very basic idea about binary search tree, maybe some of you still kind of forgot about exactly the definition. We're going to look at that as well. And then we're going to look at something very cool called tree rotations. Intuitively, whenever you try to insert or delete, we talk about, I'm pretty sure you learned about insertion into the binary search tree and deletion from binary search tree, right? If you do any of those, it might break the balance of the binary search tree, meaning that the height of the tree may not be log n anymore. It's going to be gradually becoming big O of n. Okay, that's something I will show to you, don't worry. I just want to mention that verbally. And then tree rotation here is something to say every time after a single insertion or deletion, I'll check the balance for the tree. If the tree balance property is violated, I'll do rotation. And rotation, gotta make sure however way I rotate a tree, it might look very different, but it will remain to be a binary search tree. All right, that's something we'll see later. Okay? And not only that, we're gonna do the tree rotation on the paper, which will be lots of fun to really draw lots of diagram here, but we're gonna see how to do that in Java. All right, that's something we'll do as well. Okay. So my philosophy for introducing a programming component to this course, which my colleagues, maybe from 3101, from other section may not necessarily agree, but to me, I think especially as an engineering section, you cannot just learn about theories on the paper. You have to know how things work. So what we guarantee, once you actually learn about the different ways to implement trees and graph, you will be able to design your own algorithm beyond this course and make things work. All right? Oh, 1 minute, right? Okay, very quick. Okay, so I think so guys, please 1 minute, and then I'll make sure I end in time. So, and then we're gonna talk about recurrence relation. Okay, that's something I wouldn't say too much, but whenever you got recursive algorithm, it can actually express its running time using recurrence relation. Okay, and then this part here is more to do with the graph, which I will talk about them together with motivating problem. If time permits, we definitely talk about dynamic programming as an NP completeness. And one more thing I want to catch your attention. That will be something I will give you more example about. When I said you don't learn about any new sorting algorithm, I didn't lie, but you might be thinking I'm lying. Because you can see there's a word over there called topological sort. All right? Topological sort is something you will also hear a lot about graph algorithm. Clarify day one. Topological sort, yes, it's a sorting algorithm, but it's not exactly the kind of a sorting from smaller to largest kind of sorting you learn about in 2101. Anyway, I'll see you guys on Wednesday, and we'll talk about motivating problems.